Hi all, this is lecture 21 on 5.6 exponential and logarithm functions. So we are going to combine our use of exponential and logarithmic functions together to solve equations, okay? So the key thing we need to remember here is that exponential and logarithmic functions are inverse operations, okay? And that means that they are paired together just like add, subtract, just like multiply, divide, just like square and square root, okay? So to get rid of a log, you would use a base, an exponential of the function of the same base. To get rid of an exponential function, you can use logs, and you can actually use any logs because of the properties of logs. So keep in mind here that we have these two things. So if for inverse functions, when you compose them in either order, you get back whatever you had. So if you take an exponential and then take the exponential of a log, you get exactly what those two kind of cancel out and you just get the x. Same thing if you take the log of the exponential. Those two pieces cancel and you just get the x. That's the same if it's a common logarithm. So a base 10 and a common log have the same base, so they're going to cancel each other out, whether you take the 10 first and then the log, or the log and then the base 10. You still get the x. Same thing is true for our e's and ln. So e to the ln cancels and ln of e both cancels. And we just get whatever it was sitting there, okay? So that's what we're going to use to solve our equations, okay? Now, we can use any kind of logarithm when we're solving exponential functions. So we're going to solve the same one in two different ways. First using common logs and then using natural logs. So if we start from 5x equals 3. Right now, the problem with solving this is that my x is in the exponent, and I can't use any kind of add, subtract, multiply, divide to get out of that situation. So what we're going to do is we're going to take the log of both sides, and we're going to use common logs, so log base 10, just like this. And we're going to do it to both sides, just like if you were adding 2 to both sides, or taking the square root of both sides. So we're going to take the log of both sides. Okay, now you have to take the log of everything that's there, right? In this case, it's just a 3 and a 5x, but if it was more, if it were 3 plus 2 or 3 plus x, I'd have to take the log of that as well, like log of 3 plus x, okay? Now, what I can do is I can use the property of logarithms to handle this x right here. So my properties say that this x can come down in front. So that's what we want to do next. Let's do that. We bring that x down in front, and then I have x times the log of 5 equals the log of 3. And now what's happening between my x and this logarithm is multiplication. And to undo that, I would divide. So I'm going to divide by log of 5. Now, log of 5 looks a little scary and different, but it's really just a number. If I put that into my calculator, it's going to give me a decimal value. So I can treat that as if it were a 7 or a 17 or a 12. So that leaves me with x equals the log of 3 divided by the log of 5. And I can go ahead and put that into my calculator. Now, this can be a little bit tricky if you're using a scientific calculator without rounding your values. So I do recommend that you can go to something like wolframalpha.com. You can see up here at the top, right? My Wolfram Alpha. And then I can just plug things in here. So I can just type it in the way I want it. So log of 5, no, I said 3 is first, right? Or the 3 is on top, divided by the log of 5. And then we get this decimal. So it'll always pop up the answer to you right away. So point in there in orange. So 0.683. So this is equal to 0.683. Okay, now you do kind of want to check to make sure that that makes sense. And we can take 5 to some power, and that's going to give us the 3. You just want to make sure that you don't get anything like logs of negatives or zeros. That would kind of change things up a bit. So that's solving using common logs. We can also do the same thing, but use a natural log instead. So if we start from the same place, 5 to the x equals 3. And instead of taking the log of both sides, we use the natural log. So take the natural log of 5 to the x and the natural log of 3. Then we're going to use the same property because those properties hold regardless of what the base is. So this x can come down in front. And that will mean that we get x times ln of 5 equals ln of 3. And now again, we're in that same situation where our x is multiplying the ln 5. So if I divide both sides by ln 5, the number ln 5, I will be able to get my x by itself, right? So that'll give me x equals natural log of 3 divided by the natural log of 5. And again, we would just go to our calculator and calculate this, okay? And if all goes well and we did it right, then we should get the same exact answer. Whoops, hold on. I want the natural log, wait, hold on. What just happened? Let's go back. There we go. And I'm going to change my logs to ln's. Why did it change it to pounds? There we go. ln 3 divided by ln 5 should give me that same 0.683. So I got the same answer regardless of which logarithm I used. And that should always be true for exponentials. And that's why, for the most part, in calculus, we always go with natural logs. We'll always use the ln's, okay? So unless it tells me to use common logarithms or something else, I'm going to usually use my natural logs. All right, here we go. This one's a little bit more involved, so let's see what we can do here. So we have, again, an exponential function. They want us to use common logs to solve it. So the first thing we're going to do is take the log of both sides. So I have the log of 4 to the 2x plus 3 and log of 5 to the x minus 2. Okay, these are both log base 10s, right? Then I'm going to use my property on both pieces. I'm going to take this 2x plus 3 and bring it down, and the x minus 2 and bring that down. And that's going to give us 2x plus 3 in parentheses, because it's two things, times the log of 4. And over here we have x minus 2 times the log of 5. Okay. Now log of 4 and log of 5 are just some decimal value, and so I can go ahead and distribute that inside the parentheses. Okay, it looks funny, but it is correct. So I'm going to have 2 times log 4 times x plus 3 times log 4. On the right, I have log of 5 times my x minus 2 log of 5. And now I'm trying to solve for x, and I've got an x here and an x here. So I'm going to put those on the same side and everything else on the other. So I am going to subtract the log of 5 times x. And then I'm going to subtract the 3 log 4 and move that over here. And that way, I'll be left with 2 log 4 times x minus log 5 times x equals negative 2 log 5 minus 3 log 4. Now on the left-hand side, I've got 2 x's there, 1 in each term. So that means they have each term, those two terms have a common x. So I'm going to pull that all the way out front. Okay. And then the last thing I'm going to do, my x is multiplying everything in parentheses. So I'm going to divide by everything in the parentheses. And that's going to leave me with a final answer for x of negative 2 log of 5 minus 3 log of 4 all over 2 log 4 minus log 5. All right, so we're going to then try to put this into our Wolfram Alpha. So here we go. I don't know why my keyboard got so small. All right, so parentheses first. Negative 2 log of 5 minus 3 log of 4. Close the parentheses because that's my numerator. Divided by parentheses. Oh, I missed the 3 log 4. Is that what I was supposed to have? Nope, that was right. Okay, good. 2 log 4 minus log 5. So 2 log 4 minus log 5. Close my parenthesis. And you can see it adjusted my number here. And I end up with negative 6.34. So this is negative 6.34. Okay, and that's the value that's going to work for me. All right, so we can do all of that using logs. Now it gets a little more complicated because you have to distribute and reorganize your terms, but it does work. We can do the same kind of thing using natural logs. So the process here looks identical, only we're using ln's instead of logs. So that means we're going to take the ln of both sides. So we have the ln of 2 to the 2x minus 3 and ln of 5 to the x minus 2. Use the property that brings down each of our exponents. So this will be 2x minus 3 times the natural log of 2 and x minus 2 times the natural log of 5. And then same process. We're going to go ahead and distribute that to both terms inside the parentheses on both sides of the equation. That's going to give us 2 ln 2 times x minus 3 ln 2. On the right-hand side, we get natural log of 5 times x minus 2 natural log of 5. And then again, we're going to look for those x's. I got one on the right, one on the left, and I want to combine them on the same side. So I'm going to subtract the natural log of 5 times x. And I'm also going to subtract the 3 ln 2. So I want everything with an x on the left and everything that does not, moved to the right. And I should be adding that, shouldn't I? Hold up. Did I do that correctly up here? Oh, I changed the problem a little bit. So it's slightly different. Okay. It's not the same problem. That's what I was checking. Okay. All right. Now, when things cancel, these cancel out, these cancel out. So I'm left with 2 ln 2x minus ln of 5x equals negative 2 ln 5 plus 3 ln 2. Now, I've got my two x's. They're both on the same side. I'm going to go ahead and factor it out front. That leaves me with 2 ln 2 minus the natural log of 5 in parentheses. And that's equal to negative 2 ln 5 plus 3 ln 2. And then my last step is to go ahead and divide by everything in the parentheses. So I'm dividing by 2 ln 2 minus the natural log of 5. And that's going to give me x equals negative 2 natural log of 5 plus 3 natural log of 2 all over 2 natural log of 2 minus the natural log of 5. And we want to get a decimal value for this, so let's go ahead and plug it in. So 2 ln 5 plus 3 ln 2. So 2 ln 5, so it's close. It's very similar. Minus 3 ln 2. Oh, it's plus 3. That's what I thought. And then 2 ln 2 minus ln 5 on the bottom. And 2 ln 2 minus ln of 5. And that gives us negative 23.74. Okay. Now, if you don't have a graphing calculator that you could enter this into nicely, then either you can do your best with rounding, like round to one decimal place and do that on a quiz or a test. Or as long as you have it written out this way, I would give you credit for that. I don't need a decimal equivalence, okay? All right, what do we got left? We have 2 examples left. Whoa, hold on. What is going on here? Let's see. I'm pretty sure one of those equal signs is supposed to be a plus sign. So let's make this one here a plus sign. Okay. All right. Now, this is not an exponential equation. This one is a logarithmic equation. And the first thing I'm going to do to solve this is I'm going to try to put all my x's together. So I'm going to move my logs both to the same side, and I'm going to condense them into one log. So the first thing I'm going to do is I'm going to subtract the log of 2x minus 3 from both sides. And that will give me the log of 5x plus 1 minus the log of 2x minus 3 equals 2. Then over here, I'm going to put this back together on the left using a single logarithm, right? And they are being subtracted, so that means division. And the positive one goes up top, and the negative one goes on the bottom. And that's still equal to 2. So now, in the past, we said, oh, well, let's just rearrange this. Well, instead, what we can do is we can say, okay, well, if I want to get rid of this log, then all I have to do is use the exponential function with the same base. And the base of that log is 10 because it's a common log. So I'm going to take 10 to both sides. So I'm going to make it 10 to the log of 5x plus 1 over 2x minus 3. And 10 to 2 with a squared power, right? So I'm going to make what's on each side the exponent of my power. Now what happens here then is that these two are inverse functions, and those two will go away, and we'll get 5x plus 1 over 2x minus 3 equals 100. From here, this goes back to solving our rational functions. So I'm going to go ahead and multiply both sides by the denominator. And that will cancel it on this side. And we're left with 5x plus 1. And on the right side, let's go ahead and distribute that. So that gives me 200x minus 300. And then I'm going to collect my x's on one side and move everything else away. So let's subtract 5x from both sides. And let's add 300 to both sides. And that's going to give me 301 and 195x. And so then all we have to do is divide both sides by the 195 to get our x by itself. So we get 301 over 195, which looks like a funky fraction, but that's okay. Nothing wrong with it. Okay. All right, same kind of thing with the natural log over here, and pretty sure this was supposed to have parentheses around it. Okay, so what do we have going on here? Well, let's see. We have 3 natural logs going on. So let's put this back together. So I'm going to subtract this ln on the right from both sides so that I can get all of my ln's on the same side. That gives me the natural log of x squared plus 4 minus the natural log of x plus 2 minus the natural log of x minus 2, and that's equal to 2. Then I want to put this back together as one big logarithm. So that means anything that's positive goes in the numerator. So the x squared plus 4 goes in the bottom, and the x plus 2 and the x minus 2 goes in the denominator. Okay. Now, what do we do next? Well, we can say this. We can get rid of this natural log here by using the proper exponential function. And that's the natural log has base e. So I can raise both as a power of e. So take the e of both sides. And that will cancel out my e and my ln. And I'll be left with this, x squared plus 4. And if you multiply that out on the bottom, that gives you x squared minus 4 equals e squared. And then again, we're right back where we were last time. So we're going to go ahead and multiply both sides by the denominator to clear out that denominator. That'll leave us with x squared plus 4 on the left and e squared x squared minus 4e squared if we distribute on the right. And again, I want to put all my x's on one side and my numbers on the other. So we're going to subtract an e squared x squared. And let's subtract a 4. And that will leave me with x squared minus e squared x squared equals negative 4e squared minus 4. All right, now I'm going to factor both sides of this. And I'm going to get x squared times 1 minus e squared. And then I'm going to, let's see, we can factor out a negative 4 here. And that gives me e squared plus 1. And then I'm going to divide both sides by what's in front of my x squared. So 1 minus e squared on both sides. And they cancel over here. And I just get x squared equals negative 4 times e squared plus 1 over 1 minus e squared. And then the last piece would be to take the square root of both sides. Don't forget your plus and your minus. Okay. All right, now something we want to check on. Anytime I get an x with logarithms that's negative, it makes me a little bit nervous. So let's see what this value represents. So if I go to my Wolfram Alpha and I type this in, I want to know what is the square root of, parentheses again, negative 4 times e squared minus 1 divided by 1 minus e squared. And what did we get? Oh, we got 2. Hold on, I think I have a sign wrong. Oh, yep, it's plus. This one is plus. All right, so we get 2.29. So this is equal to positive and negative 2.29. Now, if we go up here and we plug that back in, so this one here, always going to be positive because I'm going to square it and add stuff. Here, I'm taking a negative 2.29 and adding 2, and that is not going to be positive. So that's going to cause a problem. It's also going to cause a problem here. If you take a negative number minus 2, that's going to give you a negative number, and we can't take the natural log of negative numbers. So here, we don't want the negative. All we want is the positive 2.29. Okay, so do watch out for that. Anytime you get a negative number, you want to check and make sure that it doesn't create a problem in your natural logs.